All right, well, thanks everyone for showing up on this Tuesday afternoon. Like I kind of mentioned, Python User Group is dormant for a while, at least a few months, if not a little bit longer. We started it back up about a month ago. I hosted a talk about using the Fast API module. We're back at it again here a month later with another talk entitled Typing for Fun and Profit. We're going to talk a little bit about Python and how it's a type language, or is it a type language, and just trying to answer some questions to someone who's maybe not super familiar with Python or is familiar and just has never really looked into it. I know I had to do some research preparing for this talk, so I definitely learned some things. For those of you who don't know, my name is Joseph Riddle, software engineer here at Intelitech in downtown Spokane. Yeah. Let me move that. The Spokane Python User Group is currently now sponsored by the Spokane Tech Groups, a group that kind of encompasses a few of these user groups here in Spokane, .NET Users Group, which is pretty active, as well as the DevOps group, which I think meets twice a month, and then now the Python User Group. It's sponsored by the company I work for, Intelitech. And we're actually hiring. There's a slide later. We just got a few people in the call, but for those of you in the call and anyone who might come and watch it, we are actively looking for a Python developer. So this seems like a good spot if to find a Python developer if anyone's interested in. Next .NET User Group, looks like it's September 14th. Mark Michaela, CEO of the company, and Kevin Boss are going to talk about nullability. We also have tonight's Python User Group meetup on June 15th, and currently it's set for a monthly cadence, the 3rd June of every month. So we'll see what next month brings as far as talks go, or topics go. And finally, the DevOps group, next meeting is July 15th. I think it's a continuation of Phil's last talk about containerization. And he'll be talking next month about using Kubernetes. The social medias for Intelitech, I believe the link to this video will be on the YouTube for Intelitech, if not a different YouTube channel. So give it a follow. And like I said, we are actively hiring both a Python developer and a Node developer, and always looking for skilled people, even if you don't match either of those currently. Meet today's speaker, that's me. I already introduced myself, so let's hop over to the other slides. And can you guys still see that screen, the Typing for Fun and Profit, the cutting edge blank white PowerPoint?
Yes, sir.
Awesome. All right, so like I said, Typing for Fun and Profit, the goal is to answer some questions about Python. Is it a type language? Is it dynamically typed? Is it statically typed? What do those even mean? Is it strongly typed, weakly typed? Can you use type hints in Python? We're just going to kind of go at a fairly high level over all those sorts of questions. And maybe if you're new to the Python scene or haven't used it since like Python 2. something, so for quite a while, or you've just never used really type hints in general in Python, I'm just going to try and give a nice introduction to a kind of a few different topics. Last month we had a lot of code samples. Definitely had some code samples go wrong mid-presentation. This month's presentation will be a little light on the code samples. It's more going to be talking, but I do have some a little bit later in the second half of the presentation, so we'll look into those. Should go about an hour to an hour and a half. With less code samples, this one might go a little bit quicker than last month's, but let's get into it. Outline, first things first, we're going to talk about static versus dynamic, and then strong versus weak typing. We'll talk about a common term in the Python sphere, duck typing. What is it? What does it mean? What does it mean in the context of the other bullet points? And finally, we'll hop into the typing module that's built into Python. I just want to give some kudos or appreciation to people who I don't know personally, but whose other presentations definitely helped me prepare and understand as I was moving forward. These links are definitely videos worth taking a look at, as well as reading. And I will actually drop real quick in the chat, because I forgot to do that, a link to the repo where you can follow along with the slides, or go at your own pace if you'd like. It is public, so all my code samples and slides are there. The slides are actually in a markdown file that I generate into a PowerPoint. So I included both the PowerPoint and the markdown file, in case you didn't want to look at the markdown because it's kind of ugly. First things first, static or dynamic, what does it mean? It's actually, this one's a little bit easier to answer than the strongly typed versus weakly typed, in my opinion. A static type language basically means your type can't change at runtime. These bits in the quote blocks here are actually taken from that link on the bottom on Python's wiki. It specifically kind of addresses this question, so I highly recommend checking out that link. It definitely goes into more detail, and parts of what I talk about here are definitely taken from that link. So if static is a type that can't be changed at runtime, then dynamic would be the opposite of that. It's basically a type that can be, is both determined at runtime and can also be changed at runtime, both of those things. Again, taken from the documentation, it's Python, when it says it's referring to Python, is very dynamic, rarely uses what it knows to limit variable usage. Python definitely adheres to trying to put responsibility on the developer to practice best practices. Maybe that's a topic for another talk, but that's why nothing is really truly private in Python. You just, the underscored convention to make something private, but as a developer, you can still go and access that. So just another example of where Python is kind of leaning on the developer to practice best practices. Let's look at some different languages. Which ones are static, which ones are dynamic. This list was taken from another presentation, so apologies if you disagree with parts of it. I certainly am not very knowledgeable about some of these languages, including Ruby, Clojure, and Rust, ones that I haven't even never really used. But you can see up at the top, Python is dynamic with a little asterisk. We'll discover more what that asterisk is indicating later in the talk, but it is dynamic. Versus a language like Java, for example, where you can see on the bottom example, we create a variable and we're going to name it thing and assign it to 42. And if we print that out, and apologies, I forgot to show that it's getting printed out there, but that would print out the number 42 on the console or command line. But if we try and set thing equal to hello, a string, we'll get the error actually on the bottom there. Java doesn't like that we're trying to implicitly convert this variable thing from a integer to a string type. And so it's actually going to throw an error when we go to run that. If we backtrack a little bit up towards the Python example, you'll notice that we're doing a very similar set of logic. We're going to set thing equal to 42. And when we look at the type of the variable thing at runtime, we see it's an int. So everything's good there. And then we also go ahead and set it to the string hello, and we're not going to run into any issues. Because Python is a dynamic language, we can change the type of a variable at runtime, and it's also determined at runtime. So the variable type is going to be determined by the interpreter of Python as it's executing that line. I won't go too in the weeds about the interpreter, but it's basically how it's working. Moving to kind of the next question I want to answer, and actually before I move forward, can I answer any questions about static versus dynamic? I will talk about it a little bit more after I answer the next question, but pause for questions for just a moment here.
Maybe you could talk a little bit about any kind of problems you've ran into with that flexibility.
Yeah, that's a great question, Reese. I'll probably talk about that towards the second half where we get into some more examples. But there's definitely times where you may run into issues where, for example, if we're using thing to do, maybe we want to add some numbers together and then we accidentally set it to this string hello. Python will let us do that, but we may get a runtime error if we try and say add thing to another number. We're going to run into an issue. And that actually segues really great into the next portion, strongly typed versus weakly typed. So great question, Reese, and I will talk about that a little bit.
Okay, thanks.
Any other questions? Okay, we'll move right along. Next topic, strong versus weak, or strongly typed versus weakly typed. This one's a little bit harder to define, and actually in doing research on this exact question that I've had myself, this one is a little bit less of a yes or no or a binary true or false. And it's a little bit more of a spectrum between strongly typed and weakly typed. If you start to look really into the definitions of these, there's kind of varying definitions, but at a fairly high level, a strongly typed language is going to restrict in some ways, how different types can be intermingled or used together. In some examples in the next slide or in 2 slides from now, will help clarify that a little bit. So the opposite of that, a weakly typed language will, the compiler or interpreter will oftentimes try and do its best to make assumptions about what you might be trying to do, and will maybe change the type of the variable to make your code work, but it might not necessarily work in the way you think it will, as we'll see in a second. Some more examples. Again, this was just taken from Wikipedia. I haven't really worked with Clojure or Ruby that much. I've worked with Python and JavaScript and a little bit of C. C and Java, not since school, but have worked with Python and JavaScript a decent amount. So if anyone disagrees with those, my apologies. It may need updating, but that was taken from Wikipedia. An example, Python here, Python being the strongly typed language, we'll go ahead and set foo equal to 42 and set bar equal to no thank you, just basically a string and an integer. And what we'll see when we try and add foo and bar together is that Python actually doesn't let us do that. It's going to throw a type error saying, hey, you can't add an integer with a string. That's not okay. But if we look down at JavaScript, a weakly typed language, and do relatively the same lines of code, foo equal to 42, a number, and bar equal to yes please, a string, when we add those together, we might get a potentially unexpected result. You might expect to see an error similar to Python, but that's not the case. We'll actually see that if we printed that out, we would just get the number 42 concatenated with yes please. So it's just going to go ahead and print a string out. I've certainly run into errors in my time with JavaScript where I accidentally combine different types of variables, oftentimes a number with a string. And so that you could say is maybe one disadvantage of a weakly typed language. And I don't say that there's necessarily one's better than the other, but there's certainly some differences to be aware of. And in this case, Python is strongly typed, and JavaScript is an example of a weakly typed language. Here, I used my very best MS Paint skills to draw a little chart. You can see that I crudely erased C and moved it where it belongs. That was kind of for fun. But this is what I really want to illustrate with this amazing illustration is that strong and dynamic don't necessarily go hand in hand, or strong and static don't necessarily go hand in hand. Weak versus strong, dynamic versus static are in some ways orthogonal to each other, where you can have different combinations of the two from each comparison, if you will. So this is just an example of we have these different popular languages that live in different quadrants of this graph. The one in the bottom right being Rust, which I again don't know that much about, so apologies if it doesn't belong there. Looking back at the last few slides, just to recap, hopefully what you have learned, if you weren't sure what the answer to the question, is Python weakly or strongly typed? Is it dynamically or statically typed? Is that Python is strongly typed? It restricts how types will interact together. And it's also dynamically typed because types are determined at runtime as well as can change. Like I said, if you're around the Python sphere or coding in it a lot, a term you're probably very familiar with, but may not actually know what it means, is duck typing. If you go to the Python's glossary, they actually define it for you, which is great. I'll just read it. A programming style which does not look at an object's type to determine if it has the right interface. Instead, the method or attribute is simply called or used. Very common example is if it looks like a duck, quacks like a duck, it must be a duck. And this actually is similar to another concept that you may have heard in researching typing, is the idea of nominal versus structural subtyping, in which duck typing is actually very similar to structural typing. Basically what nominal means is if foo inherits from var, foo is a subtype of var because we've named it thus. Thus the name nominal. We're naming our super type as var, and apologies, there's a typo there that it should be var instead of var. What Python allows with duck typing, kind of the best practice that it pushes you towards in some ways, is to use structural or duck typing. They're not exactly the same thing, but they're relatively similar. Basically, if foo is a subtype of var, not because you explicitly say it is, but because its structure matches var. For example, if they both have the same function, then you could say that they are structurally, or the one may structurally be the subtype of another because of that function. We'll talk about this later towards the end. I've got some examples that will illustrate this a little bit better. Here I'll pause for some questions on anything before we jump into some more concrete examples and some code samples.
Would you say that, just real quick, would you say that learning Python is a quick thing to do, as far as languages go, or does it take a long time to really master it?
It's a good question, Reese. I would certainly say that I haven't mastered it or come anywhere close to it. That being said, I do feel like, especially if you have some other programming experience, it is really easy to jump into and get going and working on projects. It's become kind of my language of choice when I have an idea and just want to jam on it and not get stuck in setting up a project or getting my environment perfected before I get going. And I think it definitely has a very mature set of modules that you can use, and it's used for all sorts of applications. That being said, I wouldn't say it's easy to master. I don't know that any language is easy to master, but if you're looking for a language to learn, I'd say Python is definitely a fun one and relatively easy to pick up compared to some other languages. And especially for a beginner who hasn't programmed at all, it was the first language I ever used, and I think I'm happy with that. Scott, I saw you hopped off mute for a second. Did I talk just over you?
Yeah, that's fine. You are going to do some examples on the duck taping?
Yeah, yep, we'll have some examples, and I'm actually moving a little bit quicker than I thought, so we might hit the end of the examples and still have some time to answer some questions and maybe even just make up a little as we go and dive into some on-the-spot code samples if you have more questions.
That's cool.
Cool. All right, moving on forward. So this is the built-in module, typing.py. It lives in Python's lib folder, which is basically all the built-in modules. And that was a little joke I threw in there. I was going to end it right there, but not really. We'll just skip right past that. I'll go back. What I wanted to do, and I couldn't get working, was I was going to have it just say, thank you for coming, and then just kidding was going to be hiding. And then when I click space, it was going to pop up. But whatever tool I'm using that exports the PowerPoint wasn't letting me add transitions. So the joke kind of fell flat, but we'll just. A brief history. I'm not going to really go into a ton of detail here. Basically, Python hasn't really had type hints forever. There's been a lot of PEPs, which I think I should really know this, but I believe it's Project Enhancement Proposal. The first P might be something different. I think it's something Enhancement Proposal. But it's basically the way through which changes are made to the Python language. New features are introduced and discussed and eventually approved and integrated into the language. So for example, if we take a peek at the top one, PEP 3107, we can see that it introduced the ability to define a function that takes in a specific variable. Basically, you can annotate what A in this case would be, whether it's an int or a string or whatever. PEPs 483 and 484 really introduced a lot of type hinting as we know it in Python, and a lot of what we're going to cover in the next several slides was introduced in those proposals. And then there's some links to some other ones. They're fairly verbose reading, and I definitely wouldn't recommend reading them for documentation purposes. If you're just trying to get an overview of what some things are that I talk about. But if you're really looking to get into the nitty-gritty details of some language choices, they are interesting to read for sure. All right, here we're going to hop in the 2-a-day typing module. The first thing I'm going to talk about is if you're wanting to move towards using type hints in Python, if you haven't used type hints at all, kind of the very introductory level, I guess, use of type hints is this typing.Any feature. You're going to import it from the typing library. Basically, what it means is your type checker, for example, MyPy or another type checker, is more or less not going to ignore it, but it's going to be compatible with every other type. Let me move forward. Here we got some examples. So for example, if we start using type hints in Python and we set thing is any, then you can see that we preserve Python's dynamic typing abilities. We're changing thing from 1 to 2, from an integer to a string to a dictionary to a function, a lambda function. These are all okay to do. And what we're seeing here on the bottom is that we have 2 functions, one without any type hints and one with type hints on the bottom. And those are, in the eyes of the type hint checker, identical. Basically, if we're not adding any type hints, the type hint checker is going to assume that it's a type of any. Another useful thing from the typing library is the union. Basically, what this allows us to do is if you're trying to implement type hinting in Python, but you maybe want to be able to pass in more than just one type. For example, if you have a multiply function and you want to take in integers or floats we could define here a new type, which we've named number, and that type is basically the union of integer and float. It allows us to pass in, as you can see here on the bottom, both an integer 5 or 10.0, a float. In the type hint checker won't complain at all. That works fine, and it'll also work at runtime. You can see in the example up above, we've created a new type that we call string or none, and that's going to be the union of the string type and the none type. And that basically allows us to set a variable of type string or none to either a string or none, as the name implies. But we'll actually get an error here if we try and set a variable of type string or none to a number or some other thing that's not a string or none. And so this is where implementing type hints kind of allows you to start building up the ability to just glance at a function and see what parameters it's being passed and what types of parameters those should be. For example, if we saw, let me actually hop out of the presentation really quick. We got time, so we'll do a little on the fly. So if we had the function add, you might have left and right, and let me crank that up a little bit. And we say return left plus right. But if I was just looking at this function for the first time, I wouldn't necessarily know what left and right expects in my actual code base. Using duck typing, we're able to pass 1 or 2, and because 1 and 2 are both integers, which int has the class int has a function defined that allows it to use the plus operator, this will work and we'll actually get 3 back. Likewise, we can pass in strings and that will work fine. You see we don't have any errors, and we'll get back foobar, and I'll actually run this to show you guys that we'll get some live code samples going, because who wants to just listen to slides the whole time? Here we'll run that example file I just created, and you see we get 3 returned here, and we get foobar returned from adding the strings together. But what we don't know, if we say we were in a code base that consisted of millions of lines of code, or maybe not millions, but just tons of lines of code, and we had a much more complex function that taked in maybe a whole bunch of different parameters and was much more than just one line of code that was doing a fairly obvious addition operator, we might not know at a cursory glance what that function expected to get passed to it. And so what type hinting allows us to do is say, hey, I expect that these are going to be integers, and if you try and pass me something else, the linter or the type checker is going to complain about that. And you can imagine, as we get much more complex functions, that this becomes a lot more useful for several reasons. It's both self-documenting. You can look at the function and see exactly what types of parameters it expects. Another way of documenting is using, blanking on the name, docstrings, I think. And you can do things like param left is an int or something like that. But then what happens if you make a change and then param left isn't actually an int anymore, it's become a string? Then you're going to run into issues where your documentation is immediately out of date, which is basically incredibly unhelpful and just wrong. And so, not that you shouldn't have documentation, but what type hinting also allows you to do is document through code. So it's always up to date, because the documentation, in a way, is based on the code itself. Another thing it allows is maybe a new developer or someone new to the project is hopping in and looking around. And they don't know exactly what's going on, but they can at least see what this function expects without knowing intimately the code base. So this is kind of a segue a little bit. We're off the presentation for a moment, but I just wanted to, I guess, discuss for a moment some of the pros of implementing type hints in your code base. And Reese, I hope this maybe answered in part your question earlier about duck typing. I do have some more examples that'll keep touching on it, but or answered one of your questions, I think.
Yeah, appreciate it.
Oh, sorry.
That's great.
Yeah, I had a question about the documentation. Was that what you just entered in a bunch of text? That's how you do the documentation? And then how does that surface? Like if you hover over the add method, does it show you what that is, or? Do you know what I mean?
Yeah, so okay. Yeah, you can see right there. So yes, this is the way to do Python documentation. I think there's a couple variations on it, but basically this is the way to do it. I guess, yeah, we have time, so I'll segue real quick. The standard is if you're just going to have a one-line documentation for a function is basically the way I wrote it right here, some function that's just, or some string that's describing the function. You'll notice that we're using triple quotes. This is different than just a regular Python comment, which is denoted with a I want to say hashtag, but there's a real word for it. That's not hashtag, but basically a hashtag. The number sign. I think there's a different name for this. But anyways, this is just a regular Python comment, and you'll notice if we put this right underneath the function, we're not going to get that nice message when we hover over it. So this is the way to add description to a function.
Do you only get it when you hover over like line 1, or if you hovered over add on line 9, would that show you the? Oh, cool.
Yeah. So it's going to be probably similar to, I don't know, documentation for like a C# method would show up throughout Visual Studio or something like that. Really, any IDE or tool that's built kind of to use Python, it should have the ability to go and grab that function doc string and display it for you. And then another convention that is relatively frequent is something along the lines of returns int, something like that. Maybe like param left is an integer, something like that. And nobody wants to spend their time writing documentation, or more than they need to anyways. At least I don't like to. And I definitely don't want to write documentation that I have to now go and change in 2 spots every time I change. Like if I change what this is named or I change the type, I got to go change it here too. So that's kind of going back to what I was saying. It's really one of the advantages of type hinting is that it's self-documenting. So I don't have to go in and both change a doc string and every time I change the parameter. But hop back over to the slide before I get too off topic. Yeah, so that was type.Union. Another cool feature in the typing module is the callable. Basically, what this allows you to do is define basically the function signature that you're expecting, maybe as a parameter, or that you're expecting a function to be passed around. You can see in the top, in the top box, we have a function called call this funky func. And what we want to do there is pass it another function, because in Python you can't pass around functions. They're first-class objects. And all we're going to do is just call that function and return its value or its result. Nothing too interesting. But if we do call this funky func and pass it a non-function or something that isn't callable, we're going to run into an issue. This error we're going to get is actually going to be a runtime error. So we won't get any lint errors in VS Code because we're not using type hints. This will all look fine, but when we go to run it, we're going to run into an issue and get this error at runtime, which is less than desirable. So if we move down a little bit, you can see that now we're using type hints. We're using the callable that we imported from the typing library module. And now we're saying, hey, func has to be something that I can call that returns an integer. The ... is basically just means I don't care what parameters it takes. It doesn't matter to me. You don't have to specify that. I just care that it returns an integer. So now you can see if we look at what was causing an issue before, we're actually going to get a error in our linter or our type checker when we before we actually run the program, saying that, hey, this isn't allowed. On the second call to it, we're just going to pass a lambda function that returns 5, and that'll work. That'll be good. And when we run that, we'll just get 5 back. Finally, just to illustrate how you would define that you want a function that has certain arguments or parameters. Basically, within callable, you define the list of argument types that you're expecting. For example, here we expect 2 ints to be passed in, and we're returning an int as the value. So we expect a function that matches that shape. There most likely is something more interesting going on in your function than just creating 2 hard-coded values and calling the passed-in function with those values, but this is a bit contrived example. But as we can see on the bottom, here we're calling this function we defined, and we're passing it another lambda function that matches the shape of the callable shape. We're passing it a function that takes in 2 integers, though I didn't use type hinting here, I probably should have. But it takes in 2 ints, x and y, and it's going to return an integer value, which is, in this case, just the x to the y. I'll pause for questions here for a moment. Callable kind of confused me at first, so I'll take a moment to answer any questions if anyone has them.
Hi, I have a question about the callable. Can you use that with like kwargs and multiple like potential variables that you're not sure you will have in the function? Will that?
Yeah. So like kwargs and args, yeah, you can still pass those.
Okay.
That's a great question.
So it's
interchangeable,
really. You know, but it's like you can use that. It's like using this is basically you can use this within your arguments, and no problem with whatever really.
Yeah. I'm trying to remember off the top of my head if you have to define a special, basically in your callable definition, your callable type definition, if you have to define that it allows star args or star kwargs. And we'll actually hop over to, let's find out, because I can't remember off the top of my head.
Yeah, I don't know. I
also noticed, Scott, your voice has changed.
I'm his daughter. I'm his daughter, the one who like doesn't program, kind of programs.
Okay.
She programs.
I'm coming from the like biostats, like R and Stata, and so I learned a little bit of Python. I'm toying with it. Anyways.
Gotcha. Well, glad to have you.
Glad to be here.
To answer your question, can we pass in star args or star kwargs? To answer that, let's just go ahead and just create a new function instead of using a lambda function, because that's a little hard to read. And for those of you that might not be super familiar with what the star args and star kwargs is this basically just a way for Python.
You mean you
go ahead.
Go it. I might go down a rabbit hole of like explaining. So you.
That's all right. I'm happy to have other people chime in. You can take a stab at it if you want.
It's when you're not necessarily sure you're going to have those arguments within your function. So it leaves a bit of like open room for whatever you're calling in theory.
Yeah, I think it's a perfect explanation. So to answer your,
what's the difference between having, so the args has one asterisk or star and the other one has two?
Yeah, that's a great question, Reese. So args is going to be basically a list of. Ooh, let me make sure I say this right.
Quargs is dictionary, I'm pretty sure, I think, and then args is just a list, potentially.
Yeah. So this is going to be, if I define it, basically a list of any. And this is going to be a dictionary of, I believe it's string to any. Yeah. So basically what this allows me to do, Reese, is I could pass in, and the function is not going to use these right now, but I could just start passing in a whole bunch of numbers, and well, theoretically. Literal 3 is, well, I should be able to. We're going off script now, and we're in for a wild ride. Let me take away those for a second.
Anyways, it should work to.
Yeah. There you go.
And that would be helpful, because then if you're passing in a super big dictionary or a long list, then it can at least pinpoint that, I guess, in theory.
Yeah, exactly. Oh, and my apologies. That was because args is actually a tuple, not a list, which I got wrong.
Yeah,
so here we would see, oh, come on. Why is it complaining? I'll have to double check. I think there's special syntax to allow star args and star quargs using type hints. Usually I don't actually add a type hint to these when I use them. I'd have to double check, but that's definitely something for me to look into. But yeah, I guess one reason you might want to use these for people not super familiar is if you wanted to maybe say you wanted to pass in more than just X and Y, you wanted to pass in it like Scott's daughter, whose name I don't know, apologies.
I'm Lauren, sorry.
Who Lauren explained allows you to pass in an arbitrary number of values. What we can do now is we can do basically for arg in args, we can do result to the square of args. So basically now we can just pass in as many of these numbers as we want, and we'll just keep squaring them until we're done with the numbers. So there's a lot of different use cases, but that's just kind of one example is anytime you want to pass in one or more of a certain value. Hopping back over to the slides. If I can find the button. There it is. The next thing we'll talk about real quick is the importing literal from typing. Basically what this allows you to do is if I wanted to get more specific than just you have to pass a string in, if I want you to pass in, you either have to pass Joe or Joseph or whatever, like 1 or 2, or like, excuse me, the actual value of something more specific than just the type. This is where you may use a literal for your type hint. In this case, I create a new type called Joe or Joseph, where you have to pass Joe or Joseph. And you can see here we pass Joe, it's fine. When you start trying to pass not Joseph, we're going to get a type hint error saying that, hey, this isn't, you define these values that you have to pass in, and this isn't one of them. Maybe an example of this is if you were reading a file and you wanted to pass the mode you were going to read the file in, so like you would only want to allow like read or write or read and write, but not like foobar or some random string, but you still want to be able to pass in a specific set of strings. This is potentially one way you could go about it. So TypeVar is pretty tightly joined at the hip with the next slide, which we'll talk about. Generics. Basically what it's going to allow us to do is define a generic type. In this case, the syntax is really pretty straightforward. The only thing to really note is, in this case, we're just creating a type of T, and you just pass in a string that's the type name. But in this case, A is going to have to be, it's a generic type, but it's of type, it has to be of type string or bytes. So let's move forward into the generic example, and we'll see a little bit how they're used. So in this example, and this is a very reduced version of something that's in my actual code base, I do have a service named cache service that takes in a generic type. So at the top of the file, we define T as a type var, and then in our cache service, we inherit from generic of type T. Basically, what this allows us to do is we can create an instance of cache service that returns the type that we're using, and so when we call get, we're going to get that type back that we've defined. And when we set, we are only going to allow you to pass in a value of the type that we define. The example explains it a little bit better. If you look at the second one, we're creating a cache service that's a generic cache service that takes in strings. In what we get here is when we get foo back from .get, we know that foo is a string, whereas in the first 3 lines, we set foo equal to bar, which is a string. So we as the developer know it's a string, but when we actually get foo back by calling get, because we didn't specify the cache service a certain type, it's just going to assume it's a type of any. So basically at this point, to the type checker, foo could be anything. It could be an int, a dictionary, a list, all sorts of stuff. Any questions on generic usage? It's definitely a little more complex than, this is the basics of how to use it, but as anyone who's probably used generic code before, it can get a little more complex than this simple example. Okay, moving forward. So this, I briefly mentioned a little bit earlier. We talked about duck typing. We talked about the idea of structural subtyping. If it quacks like a duck, if it looks like a duck, if it walks like a duck, then it is a duck. And so we want to treat it like a duck. You might be wondering, if I start using all this type hinting, do I stop using this idea of duck typing? Do I stop looking at the shape of things and just looking at the names of things? And that's actually where this typing.Protocol comes in. Basically, what it allows us to do, and I'll walk through this example, is let's say some other person were using their module, they created their module, and they created a class of duck, which has the function speak on it. Right now, it just returns quack, nothing too crazy. But we can't change duck. It's someone else's code. It's not our code. We're just using it. But we want to be able to specify, we want to be able to use type hints, but also use the fact that we know duck speaks. And so we're going to define what in Python is called a protocol. It's similar to a mixin, which other languages use. Specifically, I've used the framework Flutter in the language Dart, and it uses mixins. I think in JavaScript, a mixin is something slightly different, but anyways, basically what creating this protocol allows us to do is we can define this function speak louder, and we can say that whatever gets passed into this function has to adhere to this protocol speaks that we define. And basically what that means is whatever gets passed in to this function has to have the function speak within it, and it has to return a string. We could also create another class, maybe, I don't know, dog, and it has a function speak which returns bark. But you'll notice what we never had to do, and what we can't do because duck is from someone else's module, is we can't explicitly say that duck is inheriting from speaks, because it's not our code, so we can't go and change it. But we're still able to use sort of this idea of inheritance through duck typing or structural typing with this protocol. Basically, we can define a structure or a shape of an object that we expect, but we don't actually have to go and modify all the objects that look like that shape to be able to use them. So here we're able to call speaker.speaks, and we just turn it into an uppercase and return an exclamation mark, where it's just arbitrary, just manipulating the results of that method slightly. Any questions on protocol or duck typing? Reese, this was the example I was wanting to get to hopefully illustrate duck typing a little bit better.
Yeah, okay. So I was curious about, so instead of the class duck, what if it was like a bird? Can you use this for to implement polymorphism? Like instead of saying quack, it said like some other, chirp or something. Do you know what I mean?
Yeah, so you could, so I guess two parts to your question. You could create a class bird that returns chirp or whatever, and also pass it to our speak louder function, and that would work fine. You wouldn't necessarily use protocol to create like a inheritance between duck and bird, if that's what you mean.
Oh yeah, okay.
Yeah, you could also, something you could do is, you can do more, I guess, normal inheritance. And so this is how you would say that duck inherits from bird.
Oh, okay. So it's kind of built in like that versus the other things in the library.
Yeah, and that library is part of Python. It's built in, so it's you don't have to go and install it. You can just use it. All you have to do is import it. But this is how you would do more typical inheritance, or where you maybe want to use like polymorphism to look at something's base class or its parent or something like that.
Okay, thanks.
Here we're using optional, also from the typing module. All this really is just an alias to what we talked about earlier, the union, where we're combining, you can pass in this type or this type. So this would also be equivalent to a union in none. One thing that you will notice is we define our square function here, which if what we pass in is none, then we return none, because we don't want to try and raise none to the, we don't want to try and square none, because we'll just get an exception. But if it's not none, then we'll square it and return the value. What we'll see is if we call square, the function square, and pass in it 2, what our type hinter thinks result is an int or none, even though we know by looking at it that we passed in a 2, and so we're going to get a number back based on the logic within the function. Because the function has the ability to return none or an integer, our type checker doesn't necessarily know what result is before runtime. What we would potentially want to do if we wanted to satisfy the type checker is do like a if result is not none, but we don't want to have to write that every time we're calling square when we're passing in a number that we know is valid. And this is where this idea of typing.overload comes in. Basically what we can do is overload square. We're not creating multiple implementations of the function, but we are basically telling the type hinter that, as you can see from this line, if none gets passed in, none will get returned. If an int gets passed in, int will get returned. So this is basically just helping the type hinter understand. It's basically helping it help us know what the result, what the type of the result is from the function. And then we don't actually change anything in our implementation of square. It's still the same code on the inside. But now when we call square of 2, the type checker knows that it's an integer, and we don't have to add more logic like if result is not none when we know it's not none. And same thing, we know that result is none when we pass in none because we overloaded the function and told the type hinter what is going to get returned under these certain circumstances. This is optional, you don't have to do it, but it definitely can help. And this was something that was relatively new to me. I didn't know this was a thing. There's definitely been cases where I've called a function and I know that none's not getting returned, but I still maybe want to add a none check because the type checker is complaining. But this would be a great use of overload. I think the final example is typing.Cast. Basically, there's times where we're getting stuff from other people's code, or from stuff outside of our code base. Maybe we're getting a JSON blob that we're parsing, or we're reading a config file from our system or something like that. And we know that the config file, that a certain value is going to be a string. So in this case, we know that all of our keys are strings and all of our values are integers, and we know that this config file is a dictionary. Excuse me. But the Python doesn't know, because there's no way for it to go and look at like a JSON blob and figure out what type it is before runtime. And so what we're doing here is basically telling the type checker that, hey, I know that this thing is going to look like a dictionary made up of strings and integers. I'm going to basically lie to you and tell you that that's what this type is, even though it theoretically could be different. So it's kind of this trust thing almost, where you're telling the type hinter what it is, but it could bite you in the butt a little bit if you went in and changed what this actual config file looked like. And that's, again, where Python kind of gives you the tools to kind of override some defaults and that kind of stuff if you want to. But it's up to you to kind of deal with the consequences if you do change this file and mess it up. And consequence just being you're going to get an error. Big blob of text that we don't need to read, but all it's really saying is that for some of these types, for example, tuple, list, dictionary, prior to Python 3.9, you had to import them from this typing module. So every time you wanted to declare something as being a list of strings or a tuple of strings, you had to import it from this module, which is built in, but use just an extra line of code you might not want to add. But as of 3.9, they just updated the built-in tuple class to support type hinting. So this isn't really going to change anything. You can still use the version prior to 3.9, but at some point they'll deprecate this in the future, and this will be the syntax you'll want to use. Doesn't really impact anything at the moment, but just food for thought, especially moving forward. If you're starting a new code base and you want to use type hints, then I would make sure you're up to date with Python on 3.9.5, I think, and use this new syntax, which is virtually identical. except you don't have to import anything. Looking to the future, as far as type hinting goes in Python, there's a proposal in progress for structural pattern matching. I haven't looked at this one too closely yet, but I think it's basically along the lines of a switch statement where you can use the shape of an object to determine what conditional gets triggered. So like if this object has a function on it, then go down this route. If it doesn't, go down this route. I haven't read it too closely, but it's going to be interesting, and I think it's included in Python 3.10, which is coming soon. That's the end of my talk. We just stretched right over the 7 o'clock mark. If you guys have any questions, I'd like to answer them. I know it's kind of jumping between a few different topics. They're all typing related, but kind of some different things we covered. I'm also happy to go back and talk in more depth about certain parts or answer questions that are just related to Python in general. But regardless, I do appreciate you all being here.
All right, good job.
Thanks, Reese. Thanks for your questions. I appreciate you hopping in, and yeah, thanks for the good questions.
Yeah.
Yeah, I really appreciate the time you put into this. Thank you.
Thank you, Scott, and thank you to Lauren,
Yeah,
I think it was.
Yeah, Lauren. I had one little thing about when you're using this typecast, the typing. If you can use it as a list the function will still go through, but you can still flag the conditionals that did go through as some sort of like QA, like quality assurance, to flag what values didn't match the function call, if that makes sense.
Are you talking about this last thing I touched on, the structural pattern matching?
Yeah, more so this is really cool because then it'll still push the function, it'll still quack, but could there be a way to list all of the defunct values that they still pushed through?
I think I follow what you're saying, and from what I understand, if I'm understanding,
can you tell me all of if I want to have an int, can you tell me all of the ones that were strings that Python still used, basically?
Yes,
And
I think you can even, there's ways you could do that now. Like this. There's
a way.
Yeah. So, and I want to make sure that I'm understanding correctly. So I'll hop into my IDE real quick. And so you're saying if you have
within the function, if you're still running the function and it still passes, can I know all of the values that would have failed if I hadn't given this argument?
Yeah, so there's a few ways you could do that. Maybe depending on your specific use case.
Perfect.
You could potentially do some logging and log it out and track that.
That's what I figured. There would be logging, so okay.
Yeah, you could also throw exceptions every time that function failed. So for example, if you expected arg to be an integer, and it wasn't an integer, you could raise an exception, and then whatever's calling function could potentially catch that exception and do some of its own logging or do something else to basically tell you that.
Yeah, push an SNS or something. Thank you.
Cool. Well, once again, thank you, everyone. Any final questions? Okay. Well, I appreciate y'all being here. If you know anyone looking for a Python job or other programming job, shoot them IntelliTech's website and tell them to check it out. And they're even feel free to reach out to me directly if they're interested, especially in the Python position.
Are you going to be doing another one of these talks anytime soon, or?
Yeah, Reese, so the plan is to do these monthly, the third Tuesday of every month. The last two, I've just picked a topic. So typing might not be the most exciting topic, but it's just what I've been pulling out of my hat, if you will. So if you have ideas for the next topic or something that's really interesting to you or you'd like to learn more about, definitely reach out. And I'm really happy to talk about whatever. It's just fun getting ready for the presentations and learning about them, but they are once a month.
Okay.
Cool. Well, have a great rest of your evening, everyone. Thanks for being here, and I'll catch you next month.